Today, I want to give you an introduction to blockchain development with Python. All right, you don't have to know anything about blockchain or Python necessarily to follow along with this video. I'm going to teach you everything from scratch, right? I've got several different examples that we're going to walk through step by step. They're going to teach you Python and blockchain at the same time, all right? And I've created some other videos about Python and blockchain on my channel before, and I've put them all together so that you can see them, all right? And there's a table of contents down below that you can use to skip around each part in the video, okay? There's going to be several different examples that are jam-packed full of value for you for free. So, hey, I'm Gregory from Dapp University. Be sure to like the video, subscribe to the channel. That really helps this video get found so that more people can learn how to build blockchain technology. And if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. First, I want to just introduce you to this resource. This is, Web3, readthedocs.io, where you can find the Python version and, reference this in addition to all the content that I create for this tutorial series. This is a great documentation reference where you can find all of the, examples for anything you might ever want to learn how to do with the Web3 library. So let's talk about actually how Ethereum works and how a blockchain works and how we can interact with it with this library. So basically, the Ethereum blockchain is a network of nodes, which basically means that it's a bunch of computers that all talk to one another. And all of the nodes on the network share a copy of all the data, all the blocks that make up the blockchain are on each computer. And they basically, participate in maintaining the network, right? And we can talk to a single node on the network right here and act on behalf of the entire network. So essentially, we can read data from the blockchain, we can find all the transactions, we can read information from smart contracts, we can, do all that kind of stuff just by talking to a single node. But we need some kind of interface to, talk to that node and get data from the blockchain and, make transactions and stuff like that. And that's exactly where the Web3 library comes in. It's going to give us a way to talk to an Ethereum node with Python and, get data back, send data, create transactions, all that kind of stuff, okay? And there's a lot more I could say here. Basically, we're going to talk to an Ethereum node with RPC, which is basically just a protocol for, talking to Ethereum nodes. And you can see that right here. And that's what, Web3 handles under the hood. So you don't have to build all that stuff yourself. You just get it for free. Okay. And so what we're going to do is use the Web3 library with Python to talk to Ethereum nodes, and we're going to basically just get a URL for a ready-to-go Ethereum node so that we can talk to the blockchain directly without having to run a node ourselves. It's really nice. We can, kind of get up and running fast without having to download all the blockchain data and keep it in sync and stuff like that. So that being said, the next thing you're going to want to do is head over to infura.io to get a link to an Ethereum node. And that's what we're going to use to create our connection to the blockchain. Infura is basically an Ethereum as a node service, which gives us access to the network, right? And so basically, once you sign up, we actually have a new convention here. You're going to see a way to create a project. So sign up, create a project, get an endpoint like this. Don't use my endpoint. I'll probably delete this after I create the video anyway. But copy that and keep it handy because that's what we're going to need in order to connect to our Ethereum node. All right, so let's jump in and actually start writing some Python code and talk to the blockchain with Web3. All right, so in order to get started with Web3 on Python, you're going to want to, have Python installed, have a virtual environment set up, all that kind of stuff. So once you've got all that ready to go, we can install Web3 like this. We can just say, pip install Web3. All right, so I've already got it. And I also created a requirements.txt file in this directory. So I'll show you more about that later in this video when we actually turn this into a code project. But for now, we're just gonna install everything manually, run it in the terminal, on the console, all that kind of stuff. So what we'll do now is actually take the Infura URL that you got from registration step and just make sure you got that handy. I've got mine here. I'm just gonna put it here. So now I'm going to actually open the console. Let's say Python. All right. And the first thing I'm going to do is actually import Web3 like this. I'll just say from Web3 import capital Web3. Okay, lowercase Web3, capital Web3. All right, so that worked. And what I'm going to do is take this Infura URL, copy it. I'm going to say Infura URL equals this. All right. And now I'm going to create a new Web3 connection like this. I'll say Web3 equals, so I'm going to do this, say capital Web3, Web3 dot HTTP provider. I'm going to pass in the Infura URL. Oops. All right. Oops. Sorry about that. I mistyped that. I just left the 3 off of Web3. So yeah, Web3 equals, capital Web3, and we're going to pass in the HTTP provider like this, and then pass in our Infura URL. All right. So now I'm actually just going to see if it's connected, and we can do that like this. We can say Web3 is connected. All right, it's true. So we are actually talking to Ethereum, and we can further verify this with a really easy step. What we're going to do is just get the latest block on Ethereum, right? So Ethereum is a blockchain made up of bundles of records called blocks, which are chained together to make the blockchain. Each block's got a number, and we can read the latest block number with Web3 like this. We can say Web3, we do the ETH or ETH or ETH namespace, say block number, all right? And that's the current block number. And it might change if I do it again. No, it stayed the same. But you could, whenever you do this, your number will be different. And if I do this probably 10 minutes from now, it might also be different. So I'll show you the next thing, which is actually, interacting with accounts on Ethereum, right? So let me pull up the diagram that I had a minute ago where I kind of showed you how Ethereum works. So whenever we, talk to the network, everyone who uses the blockchain has a unique address. So this is a very different paradigm from the regular web. If you go to a web application and you sign up, you get a username and a password, and you're a user of the application. Well, when you use the blockchain, you actually are a user of the entire network. And when you are a user of the network, you get an address, right? And that address is going to correspond to your account, which has some sort of balance, right? And that, balance, sometimes called, your account sometimes called a wallet that's going to have this balance. And that's going to tell you, how much Ether or Ethereum cryptocurrency that you have. And also you can store tokens in it and things like that. And you can use it to interact with smart contracts. But basically, we're going to think about it like an account and a wallet right now that actually stores some Ethereum cryptocurrency. And with Web3, we can actually find stuff out about the account, see how much Ethereum is in it. So I'm going to use my real account with my MetaMask wallet. So if you're not familiar with MetaMask, this is basically just a wallet for, talking to Ethereum. And I have a real account in here. This is the Ethereum main network. I've got some real Ether. I've got almost 3 ETH in here. And I want to read information about this account with Web3 Python. So what I'm going to do is actually get the account balance. So we can do it like this. So I'm going to go to the terminal here. I'm going to say Web3, let's see here, get balance. I'm just going to paste in my MetaMask address that I copied from my clipboard. Okay, say balance. All right, so we can see this number here. We actually got a number back. So that looks like a lot. That's not actually Ether. I wish it was Ether. It'd be great if I had that much Ether in my wallet. That's actually Wei. So Wei is kind of like a penny on Ethereum. It's the smallest you can subdivide Ether. It's actually to 18 decimal places. But we can actually convert that to Ether like this with a utility inside Web3. We can say Web3 from Wei, and pass in the balance and convert it to Ether. All right, there we go. And we can see that number matches actually what's in my MetaMask account, all right? All right, so that's how you do this in the console. And I'm actually going to turn this into a project. So I'm gonna open this in Sublime Text. And I've created a new project inside of here where we're gonna use this for the rest of the tutorial series. We'll actually write the code inside of a script, and we'll run the script instead of doing everything inside the console over again. You don't have to, open it and then load, your provider every time. Basically, we're going to put all the code inside here. So I'll just show you, a quick example of that. We can just run the script like this. You can say, import. We'll do the same stuff we did inside the console. We'll say import Web3 from Web3. Then we can import our Infura URL like this. And now we can instantiate our Web3 connection, just like we did in the console. Web3 equals Web3, capital Web3, HTTP, provider. And then we'll pass in the Infura URL. And then we can print the block number. Well, actually, let's make sure it's connected first. We'll say Web3 is connected. And we'll print the block number. Okay. And then we will print the balance. Say balance equals web3.eth.getBalance. And I'm going to have to copy that MetaMask address again one more time. I don't remember it off the top of my head. So I'll do it like this. Okay. And then we'll print web3.fromWay. We'll say balance. I'll say ether. Okay. Now let's hope I did all that right. Let's try to run the script. We'll say Python app.py. All right. Yep, it worked. So it's connected. There's the block number, and there's my ether balance. So that's a good example project. Again, I've got a virtual environment set up. I've got these requirements in a file here so that we can load Web3 every time into our project. So if you're not familiar with smart contracts, they're basically just programs that run on the blockchain. And in this tutorial, I'm going to show you an example of a smart contract. We're going to get all the data from it and, pull it down into our project and read some information about it. And I'm going to show you how to do all of that in Python. So here's the smart contract we're going to use in our example today. So this is OMG. It's a token on Ethereum. So it's a cryptocurrency that's powered by smart contracts. And that's because Ethereum allows you to create your own token without creating your own blockchain with smart contracts. And it's basically just a program that governs this currency. It's just money, and it governs people's balances. It allows them to transfer tokens and things like that. And we're going to read some information about this token. And again, this is a real, live cryptocurrency on the blockchain that is, worth a lot of money. And we can interact with it and play around with it today in Python. That's what I'm excited to show you. So let's see what we need to do in order to interact with this token smart contract in Python. So first we want to, go to our project. We set this project up in the first video. So check back in that video if you haven't already. This is pretty simple to set up. You don't necessarily have to have gone through that first video. You could just, jump in as long as you have this framework ready to go. So basically what we want to do is, pull in Web3 first. But in addition to that, we also want to import JSON. All right. And we want to get our connection to the blockchain. So we did that in the last video where we got an Infura URL to an Ethereum node. So go check that out in the previous video if you haven't already. Basically, you just got to sign up and get a link that looks like this. And now we want to actually talk to the blockchain. We want to connect to it. So we need a connection like this. We say Web3 equals capital Web3. And we say capital Web3 HTTP provider Infura URL. All right, I'm going to pass that in. And, we're going to run this as a script. And we can just check to see that everything's working. We can say Web3 is connected. I believe that's how it works. Oops, sorry. And we'll say print. All right, we'll run this script to see if everything's working properly. We'll just say Python, say app.py. All right, so we're connected. That's good. So I'm going to clear this out. So what do we need to do? We need to actually connect to this smart contract, okay? And we need a couple of pieces of information about it. What we need is an ABI, and we need an address. Sorry, my text editor is going nuts here. So what are these two pieces of information? Well, the ABI is basically just going to be a JSON array that describes what the smart contract looks like, okay? And the address is actually going to be the address of the deployed smart contract on the blockchain. And with these two pieces of information, we can actually reconstruct the smart contract in Python to interact with it and, get data from the blockchain about it. So let's take a look here. This is Etherscan where we can see the token. So we need to find the address, and we can see that right here. This is the smart contract address. We'll just copy this, and we'll go back to our project. We'll paste it in. All right. And now we need the ABI. So, what is that and where is it? All right, I've actually got the code pulled up here. So I'm going to scroll down and find the ABI. So this is what the ABI looks like. It's basically this big JSON array that describes the functions on the smart contract. We're going to want all of these in order to basically be able to talk to our smart contract in Python. So just take all this and copy it. I'm going to copy like this. Okay, copy to clipboard. And now we're going to paste that into our project like this. We'll just minimize this and say ABI is this. Oh, sorry, I had to use single quotes. All right. So now what we actually want to do is do this. I'm going to say take JSON and then loads and then do that. Okay. So now we're going to have the ABI the way we want it. Okay. So now with these two pieces of information, we can reconstruct our contract with Web3 in Python. We can say contract is equal to web3.eth.contract. We can say address, and address is going to be address, and then ABI is going to be ABI. Okay? And we can just print the contract, make sure this is working. And we'll just run the app again. Okay, so we see that no errors so far, so good. So now what we can do is actually call the smart contract functions. We want to see how many tokens there are. So we can actually go back to Etherscan and pull up that information. We can see that this total supply is like 140, some big large number, I think million, if I look at it at first glance. So we can go back to our code and actually read that number from the blockchain like this. We can say total supply is equal to contract functions and then total supply. And in order to actually get this, it's not enough just to call the function. We actually have to do additionally this call. Okay. So in Web3, there are call functions and then there are send functions. And we can talk about the send functions in another video. But basically, call just means we're reading data from the blockchain. And a send function means we're going to be writing data. And that's going to require some extra parameters like signing the transaction and paying gas fees and stuff like that. So we'll get to that in another video. But this is just how you read data from the smart contract is with this extra call function at the end, right? So now I'm going to print total supply. And we can run our app again. All right, so we got a value back. So boom, we've actually read some information from the smart contract from the blockchain. And we can see that number looks somewhat like this, but it's got a lot more. Looks like the decimal's in the wrong place. So why is that? Well, that's because the value we got back is actually the way amount. And I talked about this in the last video. So when you're dealing with cryptocurrencies, they have a decimal resolution, which basically means it can be divided by so many decimals. You can actually see it here on Etherscan. This is 18 decimals. That basically means that you can have 18 decimal places after the decimal point that show you how far you can subdivide the cryptocurrency. So it's almost like having a really small penny. So if a dollar can be divided by 100 in the US, this OMG token can be divided by 18 decimal places. All right, so what we want to do is actually convert that to the real value. So we can do that like this. We can say web3.utils, say total supply, web3utils from way. So we're going to treat this like Ether because Ether also has 18 decimal places, and so does this token. So we can just say Ether, even though it's not Ether, it's a token. That's okay. It's just saying use 18 decimal places. Okay, so let's try that. And now you should see a number. Web3, utils. Sorry, this is different language. Try this. Sorry, there's also a Python version of, sorry, not Python. There's also a JavaScript version of Web3, which I use a lot more than the Python version. And some things are just different. So I find myself doing the wrong thing in the wrong language. That's the problem of knowing a lot of different programming languages, is sometimes you just mix and match things by accident. So anyways, here is the value. That looks a lot more like what we see in Etherscan here. Okay, we don't have the commas, obviously, and you could, add some formatting if you wanted to, but this at least puts the decimal in the correct place. All right, so now we can get some more information about this. Let's say contract, look at the token name, tract, functions, say name. We'll print this. All right. All right, we can see OMG token was returned. Now let's print the symbol. All right. Boom, OMG. And then let's actually read some information. Let's do something besides just calling a function that has no arguments. Let's actually get a function that requires arguments, okay? And we can kind of go back to Etherscan and look to see what's available to us. We can go back to the code. You can read through the Solidity source code if you wanted to, and kind of figure out all the functions. Or you could just go to this read contract tab right here, and we could see some functions here that have arguments. So we can see balance of is a function on the smart contract, and we would pass in, an address to see what the balance is. So here's a fun little experiment. We can go to the holders tab and find a really rich holder of OMG, someone who has a bunch of tokens. We can actually see that somebody has, 19% of all the OMG tokens out there. So we can copy that address like this and say contract functions balance of, and pass in that, pretty rich account. And we can say call. Actually, let's, instead of doing the balance by itself, say balance. And then we'll do the same thing we did up top. We say web3 dot from way balance and then ether. All right. So let's run the app. Uh-oh. So I forgot the S. Let's try it again. Uh-oh. One more time. Oh, sorry. All right, let's try it again. All right, there we go. Now we see that this account actually has a balance returned to us. All right, so that's an example of how you can, read smart contract information from a real smart contract with Python with the Web3 library. So that's how you basically use Python to build, anything that can talk to the Ethereum blockchain, whether it's a blockchain-based application or whether you're scraping data from the blockchain for data mining or whatever you're trying to do with the blockchain. Python is a really great tool for interacting with it. All right, so in this video, we're going to continue on with our series. And, in the last video, we talked about how to, read information from smart contracts and interact with them and things like that. So this video is going to be all about sending transactions on Ethereum. So essentially, I'm going to show you how to send cryptocurrency on Ethereum with Python. And we're going to kind of go in depth on how that works. So let's kind of just jump right in. So if you go to Etherscan, I showed you this in the last video, but if you look at these things on the homepage, they're called transactions, right? So the blockchain is made up of transactions, right? That's pretty much all it is at the smallest level from all the records, right? So basically, all the history in the blockchain is made up of transactions. The current state of the blockchain is basically just, sum of all the transactions. That's how you build the blockchain state. That's how you build the state of accounts. That's how you build the state of smart contracts, things like that. Is just summing up all the transactions, basically. So whenever you send cryptocurrency on the blockchain, it creates a transaction. Whenever you call a smart contract function or you send Ether or whatever, right? Like you're creating a transaction, okay? And I'm going to show you how to create one of those in this video with Python, with Web3. And what we're going to do is basically just show you how a transaction is built, because there's several different components that actually have to go into creating a transaction when you're writing Python. And we're going to just do it in real time, and I'll walk you through it, and we'll see how it happens on the blockchain. So I'm going to minimize this. And what I'm going to do, instead of talking to the main Ethereum blockchain, I don't want you to have to risk like losing money by watching this video and following along the tutorial. And I also don't want you to have any security risks by showing private keys on screen that are potentially sensitive. So I'm going to actually use Ganache, which is a personal blockchain. It's a development blockchain that won't require us to risk any funds getting lost. It won't require us, to really do anything risky from a security standpoint. So basically, we're going to have an in-memory blockchain that's going to have Ethereum cryptocurrency on it that's not worth any money. So if you're not familiar with Ganache, you can just download it here from the Truffle Framework website. Just click download and install. It's pretty easy to set up. And once you've got Ganache running, it'll just look like this. Basically, you'll have this right here. And this is going to show you, a list of addresses, accounts that are going to have, balances. You can see 100, Ether on each account. And we can, see their address. We can see their private keys, which is what we want in this video. You don't want to show anyone your private keys for a real account. It's like your password on the blockchain. And that's really risky because that can, you can lose money that way. So that's what we're going to use in this tutorial. So first, we're going to connect to our personal blockchain a lot like we did in our previous tutorials. But instead of using an Infura URL, we're going to use a Ganache URL. We'll just say Ganache URL is equal to, I'm just going to copy the one from Ganache right here. This is just localhost port 7545. I'll say HTTP, and I'll paste in that address. And we're going to, instantiate our Web3 connection just like we did in the previous videos. We'll say Web3 equals Web3 web3.http provider. We'll pass in the Ganache URL. All right, and now we're going to print Web3 is connected just to see if this worked. I'm going to clear out all this from the last example, and we're going to run the app. All right, so we're connected. Now we can actually just try to run a transaction, just read some more information. Just double check. So Web3 ETH block number. I think that'll work. Okay, cool. All right, so let's send some cryptocurrency. All right, we need a couple different variables set up in order to do this. First, you need two accounts. The first account will just be this, account 1. Paste in some code here. Oops, sorry. Say account 2 equals another account. And then we also want a private key. All right, I'll explain why we need all these things in a moment. But first, let's just copy the first account from the list. Okay, paste it in. Oops. And then let's copy the second account. All right. And now we want the first account's private key. We want to show this in Ganache like this. Okay. Copy it and then paste it here. So really this private key belongs to this first account. And what we're going to do is send cryptocurrency, send Ethereum from this account to this account. But in order to do that, we need a private key to tell Web3 that it's okay that we send cryptocurrency from account 1 to account 2, right? So let's talk about accounts really quickly. Accounts are basically kind of like your username on a blockchain, or your public key is kind of like a username. That's kind of what your account is. And the private key is kind of like a password. So this is sensitive data. You don't want to share this with anybody for a real account. But our private key is basically what allows us to authorize transactions. It's technically called signing transactions. So we can sign transactions in Web3 with our private key to let the blockchain know that we're authorizing that the transaction is sent, that it's okay to send cryptocurrency from this first account to this second account. Okay, so we need to use this private key whenever we're signing the transaction. We need to sign it before it gets sent off. So here are the steps that we need to execute. We need to basically build a transaction, right? And these transactions that I showed you sort of on the network, they have an anatomy that we're going to go through and build and code in Python. And then we're going to sign the transaction. And then we're going to send the transaction. And then we'll get a transaction hash. And that'll show us that it was successful, and we can watch that transaction as it went through. And actually, there's a preliminary step here where we're going to get the knots. So I'll explain what that is. All right. So let's actually just build the transaction. First, we're basically just going to build a dictionary that contains all of the transaction information. Sorry, let me change the spacing. Got my text editor set up incorrectly. So first, we need some values here. We need a nonce, which I'll fetch in a second. We need the account that we're going to send the transaction to. This will actually be account 2. All right. We need the from account. Well, from account is actually going to be inferred when we sign it. Sorry. So we need the value. This is going to be the actual amount of Ether we're going to send. And this is going to be, let's just send 1 Ether. And again, if you saw the last videos where we talked about Wei, Wei is the smallest denomination of Ether, like it's Ether without any decimal places. It's kind of like Ethereum's penny. So we can say Web3 2 Wei, and we can say 1 Ether. Okay. And we also need to specify a gas limit like this. So gas on Ethereum basically is some amount of cryptocurrency you have to pay whenever you're sending a transaction. That's because, Ethereum is a proof of work blockchain that has miners on it. And the miners need to be compensated for running the network. And the miners are the ones who actually, mine the transactions that get included in the blocks that get written to the blockchain. So basically, we specify a limit for how much gas we're willing to pay. This is not actually Ethereum. This is just units of gas, which is kind of an abstract concept in itself. This is not tied to, not tied to any cryptocurrency. Think about it like gallons or liters of gas in your car. It's just a unit. And then you multiply that by gas price, okay? And then so it's like saying, if I want to fill my car up with 100 gallons of gas, that would be 100 gas, and that would say, I pay $1 per gallon, right? And that's how you get the actual total amount. So I say Web3 2 Wei, let's just say 50 Gwei. So Gwei or Gwei is just a larger denomination of Wei. It's smaller than Ethereum though. Okay, so that's pretty much all we need in order to build the transaction. This is sort of the anatomy of the transaction object, or the dictionary in this case. But we need to get the nonce. So what does the nonce do? Well, the nonce basically prevents you from sending a transaction twice on Ethereum. It's kind of based on your account's transaction history and the number of transactions you've created already. So we can get the nonce like this. Say Web3 say get transaction account, and we'll say account 1. All right, we'll build the transaction. All right, so that should give us everything we need to complete this transaction definition in this dictionary. Say nonce. All right, and then we're going to sign the transaction like this. We'll say signed TX. I'm actually going to remove some of these code comments so that we can have more space at the bottom of the file here. And then we'll say Web3 ETH account sign transaction. We'll say TX and then private key. So we need to basically sign the transaction by passing in the actual transaction that we built here. And then we need to pass in the private key to let us know that, account number 1 is authorizing this. And it's going to know it's account 1. It can rebuild the entire account from the private key. We don't actually have to pass in this at all. We just needed that for the transaction count. Now we can actually send the transaction. We'll get the hash back like this. We'll say Web3 send raw transaction. Okay, signed. And then we'll say raw transaction. Okay, so then we can get the result, which is going to be a hash. And we can print the result. All right. So let's try this. I might have made some mistakes, but let's just run the app and see what happens. All right. No, it actually worked. First time. Awesome. So if you look at Ganache, you can see that 1 Ether was actually transferred from the first account to the second. So how is that? That's awesome. So boom, it worked. But if you go back to our terminal here, you can see this looks kind of funny. So we can actually convert this to hex. We can say Web3 to hex. All right, and then run it again. And boom, there's a transaction hash, and we can see it actually in a more readable format. So if we go to transactions, we can see that same value here. All right, awesome. So you could do the same kind of thing on the main net or on a test network if you wanted to. You could just take this transaction hash and look at it on Etherscan. But yeah, there you go, guys. That's how you build a transaction in Python and send cryptocurrency with Web3 and Python. Again, you could do this on, the main Ethereum network, but for the sake of this tutorial, I didn't want to expose any private keys. I want to make this as easy as possible. And yeah, I didn't want you to risk losing your money, right? This is serious business. If you've got, any amount of funds, you want to be very careful. All right, so in this video, we're going to interact with smart contracts on the blockchain. And we're actually going to, call their functions. We're going to write transactions to the blockchain with smart contracts. And we already did a video in this series where we kind of just read some information from smart contracts. But now we actually want to do more. We want to create transactions that are triggered on the blockchain with smart contracts. And that's going to work a little differently than just, reading information from them. So in order to do that, we first need a smart contract and we need a blockchain to put it on. So I walked you through how to set up Ganache in some of the previous tutorials. So check that out if you haven't already. Ganache is just a personal blockchain that can be run for development purposes locally. So I've got Ganache set up here on my machine, running on port 7545. And now that we've got a blockchain set up, we want to deploy a smart contract to it. And instead of, going through the hassle of setting up a truffle project and all that stuff, I got plenty of tutorials on my channel that show you how to do that. Instead of that, we're just going to use Remix. So Remix is a great tool. I use it all the time, remix.ethereum.org. And I just pasted in some code here. You could put any smart contract in here that you wanted to. This is the basic Hello World canonical greeter smart contract that everyone uses in their tutorials, that basically just allows you to set a message and get a message. It's the basic read-write contract that just shows you the basics of the Solidity programming language, okay? It's sort of just how you learn your ABCs. So I've pasted this into Remix. Important thing to note here is I'm using Solidity 0.4.21, and I also have the compiler version set to 0.4.2 run. And I'm going to compile it like this, start compile. All right, and then I'm going to run it. Sorry, I've got some old information here. And I'm going to choose Web3 provider as my current environment. Okay, you should do the same. And this is how you're going to connect to Ganache. So once you choose that, it'll say, are you sure you want to connect to an Ethereum node? Click OK. And then you want to do localhost, and whatever port Ganache is running on, mine's 7545 right here. All right, so I'm going to choose 7545. Okay, and click OK. And now it's connected to Ganache, and we can deploy the smart contract. So boom, it worked. We can actually verify that on Ganache by looking at the logs or the transactions. All right, we can see a contract was created. Okay, so now we have a smart contract, and we want to interact with it on the blockchain. So we need a couple things. We need the smart contract address, which I can copy here. Let's see here. Let's open it and see. Actually, go back to compile. Let's hold on. Let's just copy the address like this. Okay. Boom. Address copied. So we can go to our text editor really fast and paste that value in there. I'm going to go to Sublime Text. And actually, haven't opened it yet, so I'll open it. Sorry, this opened on my other monitor. All right, so I'll go to app.py, and I'm going to paste in, this is the address that was deployed. So address. All right, and now we need the contract ABI. So I talked about this in my previous tutorial in this series, and ABI basically is just a JSON array that describes how the smart contract works. We'll say ABI equals JSON loads, and we're going to pass it in here. And in order to do that, we need to import JSON. Okay, we're going to pass in the ABI array right there. So let's fetch that. Go back to Remix and go to Compile and click Details. And don't copy this ABI because it's going to give you a big JSON object that's going to span multiple lines. We just want a single line. So I'm going to just, let's see, I don't think they give you a nice, easy way to do this. Let's copy the Web3 version. So I'm just going to copy this line of JavaScript and we'll just format it inside of our editor. So I'm going to do that. I'm going to remove all this junk, go to the end of the line, and copy out the JSON array. All right, so here's the ABI and the address. Now we can actually instantiate the contract like this. Important note, here's a gotcha when working with Python. You have to do this in order to format the address. We'll say Web3 to checksum address. And this is going to basically format this the correct way in checksum format. So basically like Ganache and sorry, my phone just dinged. Ganache and Remix both use like a combination of either uppercase or lowercase, and we got to do it in checksum format. Now we can instantiate the contract like this. We'll say contract equals Web3 ETH contract. We can pass in the keyword arguments, say address equals address, and ABI equals ABI. All right. And now we can read the greeting. Let's say contract functions. Let's see, greet. So we can call greet, and if you remember from the previous videos, it's not simply enough just to call the function. We actually have to say call. All right. And let's print this return value. Okay. Now let's run the app. Let's see what happens. Oops, I had an error. We actually went JSON loads. My fault. So let's try it again. All right. We have a new error. So name Web3 is not defined. All right. So now what we want to do, my fault. We actually haven't created our Web3 connection yet. So if we go to some of the previous examples, like from, let's see, whenever we wrote transactions, I'm just going to copy this out of the examples directory. So if you clone this project from GitHub, I'll have all the examples here on the side. So if I go to app.py, I'll put that back in there. All right. So that's how we connect to Ganache. So my fault, guys. So let's try it again. All right, there we go. There's the actual original greeting. All right, so now that's how you read smart contract functions. That's nothing new. We did that in the previous videos. But now what we want to do is actually write data to this smart contract. And what we want to do is update the greeting that we saw in Remix. So basically, we want to call this function right here, set greeting, okay? So we can do that in our project like this. We'll say contract functions set greeting. All right, that's the function name on the smart contract, and we'll say hello. That's the new greeting, okay? And so now we'll say transact. All right, so instead of call, that's just going to read the value, and there's transact, which is going to create a transaction on the blockchain, to do that. All right. So if you're coming from Web3.js, a JavaScript background, this is similar to their send function. So we can actually return a transaction hash here. And while I'm here, I just realized we need to set a default account in order to do this. So don't forget, whenever we are creating transactions on the blockchain, we got to sign the transactions. And we need to tell it which account we're going to be sending this from, okay? So we can do that like this, so Web3 ETH default account equals Web3 ETH accounts 0. All right, so what that's going to do is actually get this first account from the list in Ganache and make that the default account. And unlike, working with like a HD wallet provider or something, this is already unlocked. So actually your HD wallet provider is also unlocked, but basically we don't have to provide a private key like we did in the transaction video earlier in this series. Basically this account's already unlocked with Ganache and we don't have to give it a private key. It's already going to be able to sign transactions for us without giving too much information. All right, so now we can actually do this. So let's print tx hash. And let's try to run the script. We'll see what happens. I might have made a mistake. We'll find out. All right, yep, I did make a mistake. So it has no attribute functions. So, sorry, function plural. So I forgot the S. Let's try it again. All right, let's see what happens. All right, so we got a transaction hash. That's good. So now let's actually display the new greeting. So what we can do is wait for a transaction receipt. So whenever you're creating a new transaction on the blockchain, and it's got a life cycle, first you're going to get a transaction hash back almost instantly, and then you have to wait for the transaction to be mined and also confirmed. And there's also there's all sorts of steps that it goes through. And sometimes people use some terms synonymously, but basically what has to happen is you want to get a receipt back before you can say, okay, the transaction was successful. So what we can do is say Web3 ETH wait for transaction receipt. And we can pass in the actual hash. Hash. All right, and that will stop executing any code until we get there. So now we can say print once it's actually gotten the receipt. We can say updated greeting, and we can say this as a format, and pass in contract functions greet and call. So now we'll actually print the new greeting once it's changed. So we'll try it again. It's going to take a second to load. All right, there we go. So we updated the greeting, and here's the new one. All right, so let's actually change to something else just to make sure it actually did work. New greeting. All right, let's run it again. Let's make sure that we didn't just write it twice. Okay, there we go. So there's the old greeting and there's the new greeting. So we know that our script worked. Awesome. So in this video, we're going to deploy smart contracts to the blockchain with Python. And in order to do that, you need a blockchain. So I've got Ganache running here. I showed you how to set this up in previous videos, so check those out if you haven't already. And we also need a smart contract to deploy. So I'm going to use Remix, which we've also used in other videos. So you basically can just go to remix.ethereum.org. I've got the greeter contract in here. This is sort of the hello world contract, the canonical hello world contract of the Ethereum world, where you can basically just get instead of value. In this case, it's a greeting, and the contract is a greeter. Okay, so what we want to do is deploy this particular smart contract to this blockchain right here. So we want to make sure we're connected to that blockchain. First, we're going to go to Sublime Text and connect to that blockchain just like we did in the previous tutorials, where we get the URL. This is Ganache running on localhost port 7545. That's what 127.0.0.1 is, port 7545. And we can instantiate our Web3 connection like this. Okay, so this will connect the file to the blockchain. We can actually just check that. We can say Web3 is connected. I'll run the script. See what happens. All right, it's working okay. So now let's actually get the information that we need. So in order to deploy the smart contract, we need an ABI. All right. That's going to be a JSON array. And we need some bytecode. Oopsies. We're going to paste that in here. So there's a few different ways to do this, right? And the cool thing about Web3 for Python is you can compile smart contracts. You could actually take this Solidity source code and compile it down, and then get all the necessary information from that to deploy the smart contract to the blockchain. So I would show you how to do that, but there's a lot of failure points. Namely, you have to have Solidity installed in your computer in order to get the Solidity compiler. You have to get a Python version of the Solidity compiler, at least an interface, and import in your project. And sometimes those things get out of sync because the Solidity programming language is changing all the time and not everything can keep up with it. So instead of just creating a video that 90% of people are just going to fail to complete, and that's not your fault. It's just because the tools are so bad. I'm just going to show you how to do it with the ABI and the bytecode from Remix. So I'm going to go in here and just compile this. So we'll go to the details, and I'll get the ABI inside of here. So I'm just going to copy this line of JavaScript, and we'll just format it inside of our project. We'll just get the JSON array. Remove this junk. Say ABI is this. All right. And now we're actually going to load the JSON. We'll say JSON. We've got JSON imported here. JSON loads. And then do that. All right. And now we want the bytecode, which we're going to get from here. So let's scroll down and go to this object right here and copy it and paste it inside of our string. Okay. This is going to be the bytecode that we need in order to deploy the smart contract. Okay, so these two pieces of information are what we need in order to deploy it. And also, we need an account to deploy it from, which will be this one, because we need some Ethereum cryptocurrency in order to create transactions and deploy smart contracts to the blockchain. So I'm going to set the default account, Web3 ETH default account is equal to Web3 ETH accounts 0, which is going to be the first account on the list, which is going to be this one right here. All right, so now let's actually instantiate this contract. We'll say greeter equals Web3 ETH contract. Say ABI equals ABI, and then bytecode equals bytecode. All right, so now let's deploy it like this. So basically, whenever you run the smart contract constructor function, this is what the constructor function looks like in Solidity 0.4.21. It deploys it to the blockchain. Or said another way, this is the function that gets called whenever the smart contract is deployed to the blockchain. So we deploy the smart contract in Web3 for Python just by calling that function. So we say, I can get the transaction hash from that. CTX hash equals greeter, constructor. And I'll call that. And just like the last video where I showed you how to call the smart contract functions, we must transact with the blockchain by calling transact on the constructor function. All right, now let's print the transaction hash just to see if this worked. I might have made a mistake. We're going to find out. All right, so let's Python app.py. Oops, sorry, typo. All right, so it looks like I had just a little copy error. So it did work that time. All right, so let's continue on. So we've actually deployed the smart contract to the blockchain, and we can see evidence of that here. Transactions, we can see that we do have a successful transaction, and that contract was created. All right, so now let's go back to our project, and let's interact with the contract that we just created. So just like we did in the last video, we can wait for the transaction to be mined. We can say tx receipt, see ETH, Web3, ETH, wait for transaction receipt, and paste in the tx hash. All right, and we can console log print tx receipt. That's what happens when I program in too many different languages, especially with the same library. You start just doing things in the wrong language. So my apologies. All right, let's see here if this is going to run. Okay, so there's the receipt. Now we can read some information from that receipt to interact with the contract. We can instantiate the contract in Web3 like this. A contract equals Web3 ETH contract. I'm going to paste in the address. This will be the transaction receipt. Contract address. And then we'll say the ABI is equal to the ABI we pasted in above from Remix. And now we can basically call the functions. So we can say print contract functions greet call. See what we get. All right, there's the greeting. And just like the last video, we can update the greeting. We can say tx hash, which will overwrite in this case, contract functions set greeting. Hello. And we'll transact. All right, and then same thing, we'll wait for the transaction to finish. And then we will print contract functions greet call. All right, let's run it and see if it actually changes. There we go. We can see the new greeting printed out at the console. All right, guys, so that is it. That's how you deploy smart contracts to the blockchain with Web3 and Python. So like I said, there's other ways to do this. You know, I can leave you with an exercise if you're feeling brave. You can actually try your hand at compiling the source code for the smart contracts. I'll show you how to do that right now, just for your own sake. I'm not going to do it on screen just because it's kind of treacherous with all the dependencies out there. But I'll point you to the reference of how you can do it yourself if you want to do it on your own time. All right, so here it is. So basically what you need is the Solidity source code. This is the same as the greeting contract we just used in Remix. So what you have to do is you can get the Solidity source code and compile it with the Solidity compiler, right? But here's the thing. You need to install the Solidity compiler. All right, so this can be kind of tricky because the Solidity compiler keeps like updating all the time. And sometimes the version gets out of sync with the Python version or the Python interface for the Solidity compiler. And you can find yourself with facing a lot of problems. You can basically enforce which version of the Solidity compiler you want to use, but a lot of times that involves uninstalling it from your machine and installing an older version that you have to find in some branch somewhere on GitHub, and it can be a real hassle. So that's why I didn't do it on screen. But if you want to try that yourself, you can follow the documentation here at web3.readthedocs.io. In this video, we're going to talk about how to interact with the blockchain and actually look at the data from the blocks themselves. So in order to do that, I'm going to kind of pull up Etherscan here, and we're going to talk about some of this data that you see on the homepage. You see all this information about the latest blocks, the transactions, and things like that. And we're going to, actually read some of this information with Web3 with the Python programming language. So you can see some information here, like the latest block. That's actually the number for the blocks. So if you don't know what a block is, first and foremost, the blockchain is made up of transactions, right? The transactions are basically just like records in a traditional database, but they can't be changed, right? And all these transactions are grouped together into these bundles of records that are called blocks, which are chained together to make up the blockchain. And each block has a number, and we can see the latest block number here, right? And we can see the block time, right? We can see that's 13.2 seconds. So the block time is the amount of time it actually takes for a transaction to get included in a block. So if I were going to send, basically if I was going to send a transaction on the Ethereum network, it would take this amount of time for it to get included in the block. And you can also see some other information like transactions per second. That's actually the sort of central bottleneck for the blockchain. It can only process 5.6 transactions per second at its current capability. So anyways, I don't want to get into every single detail about everything you see here on Etherscan, but I want to kind of give you a high-level overview of, what this information is and how we can fetch it from Web3. So like with Python, you could essentially rebuild this entire thing just with the Web3 library itself. You could display this piece of information. You could display all these blocks. You could display all these transactions, right? So like if you were going to go click on this block, this latest block, you can see a lot of information, right? You can see it's got 165 transactions in it. All right, you can see who it was mined by. This is actually a mining pool. The reward, so it was 2 Ether. And all kinds of information, right? We can read the difficulty, total difficulty, the size, the gas used. And this is all information that we can get back with Web3 and Python. So let's go ahead and try to do some of that. So first, I'm going to minimize this. And I'm going to open this project in Sublime Text. So we've been working out of this app.py file here. And so I'm going to use this. I'm going to basically get our Infura connection, just like we did our other examples. I'm just going to paste this in here. We're going to connect to the mainnet, and we're going to read information from the blockchain like we saw in Etherscan. So if you don't have an Infura API key yet, go ahead and grab one of those. We did that in the first video, I believe. So go back and check out that information if you haven't done that just yet. So we can get the latest block from the blockchain like this, or at least the latest block number. We want to display this piece of information right here, right? This here. So we can do that in Python like this with Web3. We'll say, I'll do print, say Web3, ETH, say block number. Okay. So let's say that. I'm going to go to my terminal. I'm going to run this. We'll say Python app.py. All right. So that number looks the same. So let's see here. Let's compare them to. I'm going to open Etherscan again. Sorry. 1 second. All right, it's pretty close. 8.3 and 8.2. So there's a small discrepancy, and that could be for a couple reasons. Let me explain why. It could be the fact that just in between the time that we ran this and going to fetch the website, that it could have changed, right? A new block number could have been added. But you could sometimes also nodes have discrepancies. They're not in sync with one another. And that's something you'll find in developing for the blockchain. So next, we can also get the actual information from that block. We can say print web3 eth.get block. We can pass in the latest block number if we want to. Or let's just do this. Let's say, let's do this. Let's say latest. All right, and then we'll, oops, print latest. All right, and then we'll say get block latest. Okay, let's try that. All right, we'll run this script again, and we can see all that information was logged to the screen. Now you can see a lot of stuff that's hard to read, but if you look at some of the information, right, we can see the difficulty. See, we saw that on Etherscan. We see the gas limit, the gas used. We can see the hash. We can see the miner address, right? This is all information that you could parse yourself to, rebuild this page right here that we saw on Etherscan. Sorry, I'm pulling it up. Yeah, all this information that we saw right here, you could basically rebuild from this information that you got back with Web3 right here, right? Okay, so let's go back to our Sublime text editor. And now we can actually, get the latest 10 blocks. We could basically count down from the block number and count down by 10. So we can do that in Python like this. We can say for I, which is going to stand for integer, and we'll do a range. Say 0 all the way to 10. We can say print web3 eth get. We're going to say, I'll say block number. I wonder if this will work. Let me just try this. I don't know if this is going to work. Let's just give it a try. Sorry, my spacing's set to 2. I don't know why this is doing that in my text editor. All right, this may bomb. Let's just see. Okay, I didn't like that very much. Let's just actually read all the information from the block. So let's say get block. Try that, see if this works. All right, there we go. It's actually working. You can see all this data that was logged out of the screen. Basically, it's the same information we saw a minute ago, but it's doing it for the latest 10 blocks. We're just taking the range. We're counting down from the latest. Oops, sorry. This shouldn't be minus 10. Say minus I. That was dumb. Let's try it again. There we go. So that should actually be the integer within inside this range. So sorry about that, guys. All right, so now let's actually do the next thing, which is we're going to get the data from a specific block by its transaction. Okay, so if we see this block right here, we can basically find the block hash. So basically, if you look on here, you can see the block hash. Just by clicking see more, you can copy this. I'll go back to the text editor and I'll paste in the hash here. So hash equals this. Got to put it in quotation marks. And then we can say print web3 eth get transaction by block. And we can say the hash. And then we can actually specify which transaction we want to see. Okay. So let's do that. All right, let's comment out some of this other stuff so that we don't just see a bunch of noise in the console. All right, there we go. So now you can see some information about the transaction, right? We can see the gas price. We can see all kinds of information, the input. So this is an actual transaction object, right? So if we were to open this up, we can see 144 transactions, and one of these is the same that we were just looking at, right? You can see all this information. We can see the transaction hash, the block, the the timestamp, who it's from, who it's to, what it's for, right? So it looks like they were actually sending some ERC20 tokens, right? So that's an example of how you can, rebuild Etherscan with Python, basically. You can read all the information you want to from the blockchain. Like this can be really useful if you're doing any kind of data scraping, you're doing any kind of data analysis, you're building a decentralized application, you're building a backend for a Dapp that has to, pull some information in from the blockchain. This is a really powerful tool.